Welcome back to Arxflix. Today, we're diving into the research paper titled BPE Dropout, Simple and Effective Subword Regularization. This paper tackles a major challenge in machine translation, improving the robustness and performance of subword segmentation. Let's start by understanding the problem with the traditional byte pair encoding, or BPE. Here's an example of how BPE segments the word unrelated. As you can see, it leads to a deterministic, unique segmentation that does not expose the model to various possible segmentations during training. The deterministic nature of BPE means that for each word, the model only observes one segmentation. This limits the model's ability to exploit word morphology and handle segmentation errors. Now, contrast this with BPE dropout. By stochastically dropping some merges, BPE dropout generates multiple segmentations for the same word, as shown here. BPE dropout is a simple yet effective subword regularization method. It builds on the conventional BPE framework, but modifies the segmentation process slightly during training. At each merge step, some merges are randomly dropped, resulting in different segmentations for the same word. During training, we set the dropout probability, p, to a value like 0.1 to ensure variability in segmentations. At inference, we reset p to 0, falling back to standard BPE. The paper makes three key contributions. First, it introduces BPE dropout as a simple and effective method. Second, it shows that BPE dropout outperforms both standard BPE and Kudo's subword regularization on various translation tasks. Finally, it demonstrates that models trained with BPE dropout have better token embeddings and are more robust to noisy inputs. The experiments were conducted on a range of datasets, including IWSLT and WMT14, with different corpora sizes. The NMT system used was the transformer base model. Each dataset was preprocessed with the Moses toolkit, except for Chinese and Japanese, where subword segmentations were trained almost from unsegmented raw sentences. Let's see how BPE dropout outperforms standard BPE. This figure shows how different values of p affect BLEU scores. The optimal p value was found to be around 0.1. Here are the main results. BPE dropout significantly improves translation quality across all datasets. For datasets like ENVA and DN, the improvement is as high as 2.3 BLEU compared to standard BPE. BPE dropout also improves the frequency of subword units appearing as individual tokens. This figure shows that frequent sequences of characters appear more often as individual tokens when segmented using BPE dropout. Crucially, BPE dropout makes the model more robust to misspelled input. In tests with synthetic misspellings, BPE dropout-trained models showed significant improvements in BLEU scores. Finally, let's look at token embeddings. Models trained with BPE dropout show better understanding of token relationships. This visualization demonstrates that embeddings from BPE dropout place semantically similar tokens closer together. In summary, BPE dropout is a game-changer for subword segmentation in machine translation. It's simple, effective, and significantly improves both the quality and robustness of translations. It's an excellent example of how a minor tweak to an established method can yield major performance gains. That's all for today's dive into BPE dropout. Be sure to like, subscribe, and hit the bell icon for more updates and deep dives into cutting-edge research. Thanks for watching Arxflix, and see you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.